Hi, my name is Sascha Rothe. I'm a research scientist at Google DeepMind, and in this episode, we want to take a deeper look at the underlying mechanics of the transformer model that powers Gemma 3. We will also manipulate the internal activations of the model to modify its output. This episode assumes that you already have a basic understanding of the transformer model, including concepts like embeddings, feed-forward layers, and the residual stream. We'll be using this Colab notebook, which is available in the Gemma cookbook. So let's get started. First, we'll install some dependency and import the required Python models. Next, we will select the Gemma 3 model we're working with. For this demo, we'll use the smallest model with 1 billion parameters. To learn more about the different variants, you can take a look at the video linked in the description. In the SO configuration, we can set the intermediate values we want to surface. For now, we're only interested in the residual stream, so we enable the embedding, which is basically the initialization of the residual stream, and all intermediate values after a feed-forward and after an attention block in each layer. Later on, we will also need the top activated neurons in the feed-forward layers. We can now initialize the model and ask some questions. To make our model investigation a bit easier, we use a batch size of 1 and generate only a single token. We'll issue the prompt, "What is the capital of Switzerland?" The model continues with Bern. As a fun fact, technically speaking, Switzerland does not have an officially designated capital. However, Bern is widely considered the de facto capital, and even Swiss people will often call it the capital. For now, we want to investigate how the model came to its answer. To visualize the intermediate values, we'll perform some early decoding. Specifically, we will apply the final normalization and softmax layer to the residual stream at each intermediate output. This helper function here will do exactly this. We can see now how the model progresses through its layers from bottom to top. First, there's the green embedding layer. After that, you will see the first attention layer in red, followed by a blue feed-forward layer, and this alternating pattern continues for the number of layers. The first thing you might notice is that there is a seemingly correct sentence at the very bottom. When we get some gibberish in the middle, and towards the end we get some valid sentences again. Don't get fooled by this, as the tokens in the lower layers are shifted by 1. They are essentially the previously generated tokens, which are used to initialize the residual stream. There are many interesting observations to be made here, but I want to draw your attention to the final token in each layer. It appears the model initially considered predicting Zurich or Geneva, which are the economic centers of Switzerland, before its prediction shifted towards Bern in the final layer. So something is happening in the final feed-forward layer, and we are going to find out what. For that, we'll take a look at the top activated neuron in the feed-forward layer. For the final one in layer 25, the top 2 neurons are 1937 with a value of around -10 and 4422 with a value of around -5. We now want to see what happens if we deactivate neuron 1937. We'll adjust the bias of the gate projection. Gemma 3 uses a gate activation, so a large negative bias at 1937 will result in a gate value of 0, and therefore the entire neuron will be 0. We run the model again, and as you can see now, we get the alternative fact of Zurich being the capital of Switzerland. Another thing to note is that the activation was actually negative, meaning the original model suppressed something from the residual stream. We can run the premature decoding function on the value of neuron 1937 to check what was suppressed. By the value of neuron, I'm referring to the corresponding column in its downward prediction matrix. Here you can see the top 20 tokens associated with that value. We see several variations of Swiss and Switzerland. Interestingly, there are also the Chinese and Russian spellings of Switzerland. But crucially, Zurich appears at position 7 and Geneva at position 12. Suppressing them in the residual stream shifted the response towards Bern. Another interesting thing is that there's also Argentina encoded into the value of neuron 1937. This is a bit surprising, but also quite nice when you think of Switzerland and Argentina being similar in terms of their geographic landscapes. The final trick I want to show you is that we can not only deactivate neurons, but also boost them. If we boost the neuron too much, it will just output Switzerland at every step. So we have to find a good balance here. If we now prompt the model for the richest country on the moon, we get the answer Switzerland. And if we ask the same modified model for the largest country on the moon, we get Argentina. That's all I have for now. There are a lot of other interesting things happening in the model that we haven't touched, like code switching in between layers or the attention mechanism. I encourage you to use the Gemma 3 model and the provided Colab notebook to experiment further and discover other interesting patterns and potential applications beyond what I have demonstrated today. Thanks for watching.